Hello, welcome to Fogwing Learning Center. Today, we will be discussing about the Industrial Internet of Things. Let's jump right into it. In recent years, the term IIoT, Industrial Internet of Things, has gained significant traction in discussions around the future of industrial operations. But what exactly does IIoT entail, and how is it transforming industries worldwide? This blog aims to shed light on the essence of IIoT, its benefits, and its impact on the industrial landscape. What is IIoT? IIoT refers to the integration of IoT technologies in industrial settings, connecting devices, sensors, and machines over the internet to collect and analyze data. This network allows for improved communication, automation, and decision-making processes within various sectors, including manufacturing, energy, transportation, and logistics. Key components of IIoT. 1. Sensors and devices. At the heart of IIoT are the sensors and devices that gather real-time data. These can be anything from temperature sensors in a factory to GPS devices tracking vehicle locations in a fleet. 2. Connectivity. IIoT systems rely on various connectivity options, such as Wi-Fi, Bluetooth, cellular networks, and more, to transmit data from devices to cloud-based platforms or edge computing systems. 3. Data analytics. Advanced data analytics and machine learning algorithms process the vast amounts of data collected, enabling organizations to derive actionable insights and optimize operations. 4. Cloud computing. IIoT leverages cloud infrastructure to store and analyze data, providing scalability and flexibility for businesses. 5. User interfaces. Dashboards and applications allow users to visualize data, monitor system performance, and make informed decisions in real time. Benefits of IIoT. 1. Enhanced operational efficiency. By automating processes and providing real-time visibility into operations, IIoT enables organizations to identify inefficiencies, reduce downtime, and streamline workflows. 2. Predictive maintenance. IIoT technologies can monitor equipment health and performance, predicting potential failures before they occur. This proactive approach minimizes unplanned downtime and reduces maintenance costs. 3. Improved safety. IIoT enhances workplace safety by monitoring hazardous conditions and ensuring compliance with safety protocols. For example, wearable devices can track workers' health metrics and environmental conditions in real time. 4. Better supply chain management. IIoT provides insights into inventory levels, shipment tracking, and logistics, allowing for better coordination and optimization of supply chain operations. 5. Cost savings. By optimizing operations and reducing waste, IIoT can lead to significant cost savings. Companies can also benefit from reduced energy consumption and improved resource management. Applications of IIoT. 1. Manufacturing. IIoT enables smart factories where machines communicate with each other, leading to increased automation and efficiency. 2. Energy management. In the energy sector, IIoT allows for real-time monitoring of energy consumption, grid management, and integration of renewable energy sources. 3. Transportation and logistics. IIoT enhances fleet management by tracking vehicle locations, monitoring driver behavior, and optimizing routes. 4. Healthcare. In healthcare, IIoT improves patient monitoring through connected medical devices, leading to better patient outcomes and streamlined operations. 5. Agriculture. IIoT applications in agriculture enable precision farming by monitoring soil conditions, crop health, and weather patterns, optimizing resource use, and maximizing yields. Challenges in IIoT implementation. Despite its numerous benefits, the adoption of IIoT is not without challenges. Key concerns include 1. Security. As more devices connect to the internet, the risk of cyber attacks increases. Implementing robust cybersecurity measures is crucial to protect sensitive data and systems. 2. Interoperability. With a wide range of devices and systems, ensuring seamless integration and communication between different technologies can be complex. 3. Data management. The sheer volume of data generated by IIoT devices poses challenges for storage, processing, and analysis. Organizations need effective data management strategies to handle this influx. For skill gaps, there is a growing demand for skilled professionals who understand IIoT technologies and data analytics. Bridging this skills gap is essential for successful implementation. Conclusion: the Industrial Internet of Things is revolutionizing the way industries operate, offering unprecedented opportunities for efficiency, safety, and cost savings. As technology continues to evolve, the potential applications of IIoT are bound to expand, shaping the future of industrial operations. Organizations that embrace IIoT can stay competitive in an increasingly interconnected world, leveraging data to drive innovation and enhance their operations. We hope this information has been useful. Thank you for watching. If you found this video helpful, don't forget to subscribe to our channel for more informative content. For more details, visit our website, fogwing.io. We look forward to seeing you in the next video. Until then, take care.